It is estimated that 7 million premature deaths a year are directly caused by air pollution. And not only deaths, but long-term exposure to poor air quality can lead to serious illnesses and health problems.
When we think about air quality and how it's affecting people, there's both the people who are sensitive in real time, but there's also a long-term degradation of lung function. And so we find often that the way that we communicate about air quality is often number of deaths. But I think a much more compelling statistic is loss of life expectancy. Now we can begin to understand that it's not just about the number of deaths, but it's about months to years of life that are being lost by populations in large cities due to the poor air.
Southeast Asia is now one of the booming economies in the world, and with an increasing industrial development.
So ASIA-AQ is the Airborne and Satellite Investigation of Asian Air Quality, and we are hoping to do that in 3 cities in Asia.
There's a lot more development in Asia, and there's a lot more diversity in Asia.
All those cities are slightly different in the type of industry they have. They're in different climates, and so the weather conditions are different, and so how the pollution forms can be different.
And so from a scientific perspective, exploring those differences and that range of possibilities is very, very valuable, especially in areas that are developing and experiencing some of the worst air quality that comes with those growing pains of developing strong economies, but also trying to control the impacts of that.
And it's not only industry and large cities that can affect air quality, but also rural areas and natural sources.
It's very important to account for both the human and the natural influences, which can find themselves mixed together under different scenarios.
But whether it is natural or man-made, air pollution is an issue of vital importance to all of us.
So whether the SO2 comes from a refinery or a volcano, for air quality it doesn't matter, but for understanding what you can do about it, it's very important to know the source.
Follow us as we fly over 3 different countries and Taiwan to study the processes that lead to poor air quality. The elephant is an influential figure in many parts of Southeast Asia. This impressive mammal is present in the region's cultural history and is part of its landmarks, architecture, religion, and has even become the national symbol of Thailand. But the rapid transformation of Asia's wild forests by logging and the burning of vast tracts of land, primarily for agriculture, has drastically reduced wild elephant numbers in recent decades and endangered the species.
You know, sometimes we have the air pollution here and we have smoking. We can't even see the sun because of smoke is too heavy. It's hard to explain, you know. These animals, they like this, they calm, they relax. But when the air pollution comes, they not even stand still. They run, they're trumpeting, they're screaming, and also they're too aggressive toward each other.
Air pollution is a problem that animals and humans share since we all breathe the same air.
As populations become more urban, air quality becomes an increasingly important aspect of daily life. When you think about a city with tens of millions of people and all the activities that they partake in, they have to transport themselves, we have to deliver goods to them, we have to provide power to them. All of these processes are based on combustion, still to this day. We're trying to move away from combustion, but as long as combustion drives daily life, emissions in cities will be a problem.
You know, when you burn coal or oil or natural gas, it's not just CO2 that comes out, but also these other gases, the NO2, the SO2. And so we really want to understand both the atmospheric chemistry and the climate impacts of pollution.
Although we are transitioning to cleaner energy sources, we are still very much dependent on fuel combustion in our daily lives. This still creates pollution that we emit directly into our atmosphere.
So pollutants can be classified in different ways. One of the ways that we talk about it is primary versus secondary. Primary pollutants are those that are directly emitted. Say, think about a power plant is directly emitting nitrogen oxides into the atmosphere, or maybe a desert is directly emitting dust into the air. Secondary pollutants are pollutants that are created largely through chemistry is our focus here.
We're very lucky that the atmosphere has a chemistry that allows removal of pollutants. But the process of removing those pollutants does lead to more toxic and more damaging components before that final stage of removing something from the atmosphere.
So not only do we emit pollutants into the atmosphere, but the interaction of certain chemical compounds with the sun can create other pollutants as well.
Ozone is not directly emitted. It is produced through the combination of nitrogen oxides and hydrocarbons in the presence of sunlight.
To keep track of secondary pollutants, it is important to know where primary pollutants are emitted.
So, two secondary pollutants that we are focused on are ozone and PM2.5. Those are particulates that are small enough to get into our bloodstream. But those are created by primary pollutants. So we're also here measuring those primary pollutants and understanding where those sources are and the breakdown of those sources.
This is what air quality is all about, trying to trace what we put into the atmosphere, how it evolves chemically, how it moves from place to place, and leads to things in the atmosphere such as fine particles, which reach deeply into the lungs, or ozone, which is also a respiratory problem.
But the chemistry of air pollution is quite complex, and it also depends on the meteorological conditions and topography of each region. Southeast Asia is a vast region encompassing a wide range of countries, industries, and economic development, as well as very different climates. Topography, latitude, and weather patterns can greatly influence the formation of air pollution by affecting the chemistry involved in the process.
So in terms of that diversity, we're here in Korea right now, and in Korea it's wintertime. And there's a lot of cold temperature chemistry that's happening in terms of nitrate aerosol formation and cold air outbreaks that can bring air from China long range to Korea. And trying to understand how that affects fine particle pollution is a new opportunity that we did not have at Chorus AQ.
In Korea, we made a lot of effort to reduce the emissions. Now the mean concentration of the PM has been reduced, but still we experience haze event in the wintertime, but we do not know exactly what caused this kind of haze event.
Meteorological conditions can influence the formation of pollutants in the environment, but it is still unclear how strong this influence can be and how different seasonal patterns affect these processes.
So we want to separate the impact of a meteorological condition and the impact of anthropogenic emission. And then we may know that the current policy is still effective, or we need to change our policy based upon this result.
Understanding how weather affects the formation of pollution can help us understand how our actions contribute to the formation of these pollutants, and then whether our policies can be more effective in reducing emissions.
In the Philippines, we're looking at an area that is not monitored as well, but has a great diversity of sources. The black carbon that we saw in Manila was extremely surprising compared to what we see at other places around the world. Probably having a lot to do with the types of transportation that they use. A lot of two-cycle engines, a lot of jeepneys and other things that are very inefficient in the way that they burn. But it's also tropical, meaning that the chemistry can proceed much faster.
We have so many knowledge gaps in terms of air quality. We don't know how ozone, for example, is formed within Metro Manila and where they are transported. How much nitrogen dioxide do we have and volatile organic compounds that are necessary to make the formation of ozone? How are pollutants distributed over space and time and how they're going to be transported. Where do they go? Do they actually stay? So we have so many questions, and this field campaign will be able to answer maybe some, if not all of them.
Natural emissions and topography also play an important role in the formation of pollution and add up to the complexity of the processes involved.
The other thing that's very interesting about Manila is the presence of volcanic emissions, which we were able to see in that area. So lots of different things happening in the Philippines.
We have a very complex topography in Metro Manila. We have mountains in the east, coast on the west, central plains in the north, and lake on the in the south. So this complex topography, also makes the meteorology complex. So therefore, the interaction between aerosol and meteorology, we don't know much about that. We're starting to learn about it.
So different meteorological conditions can affect the way pollution is formed.
So for Thailand, you're looking at it yet a different setting. In Thailand, you're looking at the dry season in Southeast Asia. And that dry season brings conditions where you have less precipitation, you have less removal of the pollution, so buildups can be greater. You also have an opportunity for farmers to burn their fields, and so agricultural burning also becomes a very important source. There's still some need to understand better what is more important, whether it's the dry season or the fires. And so in the far north near Chiang Mai, we know that the fires dominate. But in Bangkok, there's still a question about how much it's still the urban emissions versus incursions of smoke into Bangkok. So tracing that gradient of composition between Bangkok and Chiang Mai will be a very important aspect of what we learn.
And not just South Korea, the Philippines and Thailand. During the campaign, the team conducted overflights over Taiwan, even though they did not base any flights there. These overflights were closely coordinated with a ground-based air quality study by Taiwanese researchers in the highly industrialized region of southwestern Taiwan.
The DC-8 dropped to just 15 meters above ground.
这也是国内破天荒的出现 NASA 的科研机。
So, despite the inability to connect in person, close communications and outreach led to strong public interest and important data collection.
The crew has spent the day flying zigzags across the island, taking samples at different altitudes.
The local scientists helped us design our flight pattern.
Its data will be used to study pollutants and air quality.
Getting and analyze the data will show the behavior of the air pollution. This is a good opportunity to make the real impact for the political and also for the general public to see the scenario that can tackle with the PM2.5 and also for the air pollution problem.
All of the information and data collected in these different locations will help governments develop more effective policies to protect their populations from the harmful effects of air pollution while maintaining economic and industrial competitiveness. Volcanic eruptions are one of nature's most magnificent and brutal spectacles. And throughout human history, this majestic and destructive power has been reflected in various cultures and religions around the world. For the Adas, an indigenous tribe of the Philippines, Mount Pinatubo is the abode of Apo na Malyari, the great protector and provider, but also a deity to be feared, as they warn their children that he will wake up and start throwing stones if they don't behave. In 1991, Mount Pinatubo exploded in one of the two largest eruptions of the 20th century, sending tons of rock and ash into the atmosphere and killing over 800 people. The elders believed this was the result of Apo na Malyari's wrath after the mountain had been drilled for geothermal heat in previous years. The eruption was so explosive that the injection of sulfur dioxide into the atmosphere created a small hole in the ozone layer. The effects of aerosol particles in the atmosphere were also visible to astronauts aboard the space shuttle. which took this image in August 1991, a little more than a month after the eruption, showing distinct layers of aerosols in the upper reaches of the atmosphere. These aerosols eventually made their way around the globe, contributing to a temporary global cooling. This event gives us an idea of the global impact of particle pollution around the planet.
So at NASA, our commitment is to understand the Earth, the global perspective. And so we are paying attention to what's happening across the world. We're also cooperating with our international neighbors to take better and better observations. And for air quality, we've determined that geostationary observations are critical because as things evolve throughout the day, it's important to understand what's happening. One look per day is insufficient. And so being able to look at the life in the day of a city under different conditions becomes very valuable.
Ignition, engine full power, and lift off.
Geostationary satellites have revolutionized the way we monitor air pollution, providing hourly rather than daily measurements. And right now, we have the TEMPO satellite monitoring pollution over the US and the GEMS satellite over Asia.
GEMS is the first one to monitor air quality in Asia region from geostationary platform. So far, all the air quality remote sensing from space has been low Earth orbit, and GEMS is going to be the first one to measure air quality on an hourly basis in high spatial resolution.
In planning for the AsiaAQ field campaign, we've been looking closely at the GEMS data to help us make decisions on where to fly and how to fly, and also help us pick the other cities that we should be trying to collaborate with.
Well, for AsiaAQ, the idea is to go to these mega cities across Southeast Asia and work with local scientists to better understand the processes, the sources, and the chemical processes that are responsible for bad air quality in these cities. We use these aircraft to fill the gap between what they can measure on the ground and the satellite now that's flying, the GEM satellite from Korea. So we're trying to really get in between there and look at how you take emissions and turn them into things like ozone and particulates, which are not necessarily coming straight out of tailpipes.
Satellites can provide us with total column pollution information, which we can then combine with ground and airborne measurements to provide a more complete and accurate profile of the various pollutants and their vertical distribution.
The GEMS satellite is getting this big picture. We are hoping by going to multiple cities, we can help test them at different latitudes and also engage with scientists in different countries. So AsiaAQ is not just the US NASA, but also the Koreans working with the US, going to these other countries and saying, we think that there's an opportunity here for you to learn with us how to make better decisions about your air quality policies.
NIER is participating in the most of the activity of the AsiaAQ. For example, several Korean researchers get on the board on DCA to measure the aerosol composition and the VOC and the black carbon, etc. And then also several ground remote sensing and the ground in situ chemical measurement. And also we are conducting modeling to support aircraft measurement planning and then also to support analysis of the aircraft data.
So I'm really excited. I'm very excited about this opportunity, not only for myself, but for the country, because this gives us an opportunity to come together and collaborate together, working with the government and with the NASA scientists that are here. And so this provides a great opportunity for everyone just to come together, the policy people, the atmospheric scientists.
Collaboration between different countries and the scientific community will help address a global problem that affects us all.
Every nation, it's very much connected, right? This is a thing about the atmosphere is, things do not respect state lines or country lines. So what we do to the atmosphere in the US affects Europe and eventually even Asia, and it's just the whole globe is really connected by the winds that are blowing.
The dragon, or yong, is deeply rooted in Korean culture and widely represented in its architecture and art. This magical creature is associated with water and weather, forming clouds as it soars through the sky. But the yong is also considered an intelligent being, the guardian of wisdom and always in search of knowledge. The NASA DC-8 and G-3, as well as Hanseo University King Air aircraft, will be our dragons in the sky for this campaign. Together, they will collect important data during this campaign to better understand pollution and the processes that lead to poor air quality.
Many people ask why we need the aircraft. Why are we coming to these countries? They see the beautiful pictures from space, from the satellites, and that seems sufficient, but it's not. So at the ground level, we can measure precisely what you're breathing and being exposed to, but we can't do it in enough places to be comprehensive. From space, we can measure the accumulation of pollution, but we're not measuring what people breathe, we're measuring the total amount of pollution. So as we look at the accumulation of pollution and the exposure on the ground, we have to understand that what happens on the ground is influenced also by what's happening above head. And so the aircraft become important for two reasons. One reason is that the aircraft begins to show us the distribution of pollution in the vertical dimension, but it also allows us to measure many, many more constituents that can provide the details necessary to disentangle what's happening and to train air quality models to be more exact and more useful for predicting the future.
We have ground-based measurements, and those are very important because they are at the breathing zone. The satellites, especially the satellite from the GEMS, Korean GEMS satellite, is also important because they are giving us hourly column values of the criteria pollutants. However, we need to be able to see, a certain set of data that will connect the ground base to the satellite. And we need a platform that can go in between the two of them.
The capability to provide integrated measurements from airborne, shipborne, and ground-based measurements. This will significantly improve the remote sensing capability and its accuracy.
Data from satellites and from the ground is very important for tracking pollution. But we also need information about what happens in between to get a better idea of how pollution is formed and transported.
Traditionally, air pollutants are measured by monitoring networks. Another perspective could be from satellites that measure globally, largely at a coarser spatial and temporal resolution. What we're bringing into the field in Asia are two aircraft that are measuring pollution from two perspectives. One is high flying. It flies at about 8 or 9 kilometers in the air, and it's doing remote sensing. It's largely a satellite-like instrument that is mapping over these megacities. The second aircraft is measuring low into the atmosphere, largely measuring in situ, meaning it's pulling the air through the instruments that are in the cabin of the plane and measuring that pollution directly.
Well, this airplane is incredibly well instrumented. So we're measuring a huge number of different molecules and compounds. So all of these countries have severe problems with particulate matter pollution. But as we've said already, the particles, some of them come out directly from tailpipes or fires, wildfires, or from dust on the roads. But a lot of them are formed in the atmosphere. They're formed from gas phase precursors, including things like SO2, nitrate, ammonia, and a whole bunch of organic compounds. And so we're measuring all those precursors, and then there's also 4 or 5 instruments that are measuring the number and the size and the optical properties and the composition of the particles, both the ones that are primary that come right out of a tailpipe and those that are forming in the atmosphere. And in the same way, we can look at things like ozone is another secondary pollutant. It doesn't come out of any pollution source. You need a mix of precursors to make ozone. Well, we're measuring ozone with several different techniques, and we're measuring all the compounds that you need to make ozone so we can try to understand how it is forming and why it's forming where in the different countries, right, at what time of day and all of these things.
Both aircraft collect information on the various compounds and trace gases to track pollution in the atmosphere. But it is not only NASA aircraft that will be involved in this campaign. During the South Korean deployment, NEAR will also contribute with 4 aircraft.
In our side, we have 4 aircraft, 2 from the Hansu University, 1 from NIMS, National Institute of Meteorological Studies, and 1 from the Sunny Air. So 2 are for in situ chemical measurement, 1 for greenhouse gas measurement. Last one is to measure the distribution of the air pollutants. These aircraft measurements will be coordinated with NASA aircraft data, but also with satellite and ground measurements.
Remember, on the ground, these are point measurements. However, in space, those are column measurements. So the aircraft with the in situ instruments will be able to see the connection, what we see on the ground and what we see from space.
So measuring from these different perspectives, from the ground, the satellite, and then the aircraft, which is unique to this campaign, will all feed into chemical transport models, which are used as decision makers in improving air pollution.
We are used to thinking of computer models as powerful tools for predicting weather patterns. But in this case, they are also key to predicting air pollution.
The goal really is to be able to forecast what would be the air quality tomorrow, maybe in a couple of days. And so this information will help to validate what the models are actually seeing.
But making these measurements and collecting valuable data in different locations with different instruments, airborne platforms, and scientists requires a lot of coordination and logistics. Running a field campaign in multiple countries is no easy task. ESPO, NASA's Earth Science Project Office, is responsible for managing this complex operation. Logistics, supplies, permits, lodging, transportation. ESPO provides everything the team needs to achieve its goals, as careful coordination and planning are essential to the success of the mission.
CLS is go for main engine start.
We have a go for main engine start. And we have main engine start. 2, 1. Booster ignition and liftoff of Discovery, celebrating its 25th birthday by racking up science and supplies to the space station.
As I watched the sun come up on the horizon, I could clearly see the thickness of our atmosphere. What I saw during those few seconds really surprised me, because the atmosphere looked scarcely thin. To think that this is the only thing that is keeping us alive made me an instant environmentalist. Seeing the planet from that perspective made me realize how fragile our planet is, and that we should be good stewards of our environment.
These were the words of Mexican-American astronaut Jose Hernandez as he looked out from space at the thin layer of gases that is our atmosphere. And it is only by sharing our knowledge and through international cooperation that we can protect and preserve the delicate balance on which all living things depend so much.
While there is a political aspect to the permissions we need to fly in these countries, the actual idea to do this work together happens at the scientist level. And so many of us in the international science community already know each other quite well and began having conversations about the idea of how could we combine multiple countries into a single effort and find a way to navigate the politics, which is quite different for every country, but the science is still the same. And so it's those scientific connections that were the foundation for getting to this point.
The first time NASA reached us more than 10 years ago, and then we reach them back and contact them back. If you are interested to study air pollution in this region, we are ready to support you, and also we will cooperate and work closely with NASA.
Collaboration is the foundation of human development and progress. It is through multinational cooperation that we can address global issues that affect us all.
Just like we did with Chorus AQ, this is a long-term relationship, and so 1 year after the AsiaQ field campaign, we are going to go back to those countries and give them sort of the rapid science synthesis report to give to each of their governments, where we'll have some policy impacts, implications, and recommendations.
Science evaluates the policy, and also science can give us direction to the policy. So this will be very critical to change our culture for the relationship between science and policy.
At the end of the day, it's in our own best interest to have as much information as possible so that we can deal with air pollution as we continue to develop our societies.
Instead of targeting just air quality, we need to help localities balance all of the factors and understand how they can improve air quality while still growing and thriving.
The benefit of this mission, this project, is not only for Thailand, but it's a benefit for the whole world, because all people will get the benefit of this. Because air pollution is not just located just only one country or two countries or one region, but it's moved around the world.
And that's why NASA's work on air quality will soon continue beyond Asia AQ, with a new campaign targeting Mexico City and other locations in North America. Because, after all, we live on the same planet. Different countries, but the same atmosphere.